Hello everyone, my name is Finding Pepper, and welcome to part 3 of terrain generation. Oh boy am I excited, because in this episode, we will be turning our pen terrain generator into a tile-based terrain generator, and using it to create paper Minecraft terrain. This will make it so much easier to use in an actual game, and also Minecraft is cool. If you haven't watched the previous episodes, I would definitely recommend you do that before you watch this, because obviously we'll be using code we wrote before. I have seen some of your projects, and I've noticed that a lot of you haven't added caves. If you don't want caves, then that's fine, but if you think you might want them in the future, you should probably add them now, while it's easier to troubleshoot with the old pen terrain generator. That's my recommendation. But anyway. This video may be the most complicated of anything I've done. I'm not sure. I think it could very well be the most complicated video of any I've created. I'm excited. I hope you are too. Let's get cracking. Now, as always, the first thing we need to do is to get assets. And you can go over to my assets project for that. And the link will be in the description. Now, here we are in the assets project. You want to find the sprite with the grass block, Terrain Gen 3, and if we look in the costumes, we see we have a whole bunch of Minecraft tiles right here. So we'll just open our backpack and drop the whole sprite into the backpack. Close the backpack up and head back over to our project. Now another thing we should probably do before we get coding is save this as a copy, because you never know what could happen to it. Maybe you mess something up and you're not sure how to fix it. You need to go back. It's always a good idea just to save it as a copy, or maybe you just like how it was before. So we'll name this episode 3. We'll open up our backpack and drag the sprite into the sprite's pane. We'll rename it Tiles. So let me just explain how this is going to work. So each frame we are painting with the stamp block, and depending on what number is in the grid list at a certain point is what costume will appear there. Start with number 1 in the bottom left, that's index 1 of the grid list, then we move up 2, 3, 4, and then after we get to the top we loop around, back to the bottom, 5, 6, 7, 8, and so on. Now the numbers at each of those places will correspond to the tile there. So 2 is the air, let's see, 3 is grass, 4 is dirt. So the numbers in those indexes will signify what tile's there, and the index is what place in the grid it is. Alright, so now we can begin coding. First we'll go into the generation actually, and we'll separate off the current generation scripts. Instead broadcast a message, start game. In the tiles, when we receive the start game, forever, we'll make a block called paint. Alright, with that screen refresh, now this is the block where we'll be painting the tiles. Alright, now I'd like to make a variable that will hold the size of the tiles so we can easily modify them. We'll call it tile size. That's going to be the size of every single tile. We'll set it to 32. And make sure to drop the paint block in the forever loop. So first, at the beginning of the frame, we'll erase all the tiles. And up before that. Then we can set our size based on the tile size block. Set it to 100, and we'll multiply it by tile size divided by 16. The costumes are each 16 by 16, so that's why we're dividing it by 16, and if it's 16 it should be a size of 100%, so that is that formula. Now we also need to make a new variable for camera Y. First, because we'll be scrolling upwards as well as side to side. Now we can write code to use the camera Y if we'd like. Let's do that right now. I'll also change this to start game. I just like that name a little bit better. I'm going to separate off this block because we will not use that for now. Change camera Y by up arrow minus down arrow, right? Because we're moving vertically. And if camera Y is less than 180, Then we'll set it to 180, that's the lower bound. Now we'll make a new variable back inside the tile sprite called grid X for this sprite only, and grid Y. Now, I should take a moment to thank GriffPatch for this tile scrolling code. He uses it in his Scratch RPG series, and it's great code. I am using it here because it is great code. And if you haven't checked out GriffPatch, if you don't know who he is, if you haven't watched his tutorials, I highly recommend it. It's taught me a lot about Scratch. Anyway, I'm going to set grid X to camera X minus 240. I'm going to start in the lower left of the screen to stamp the tiles. Right, we're going to start in the lower left and then move our way up. Then come back down and then move our way up again. So to get to the lower left, we need to subtract 240, subtract 180. So grid Y, we camera Y minus 180. Make another variable called grid index for the sprite only. The grid index will keep track of the current index of the grid that we're stamping at. To find the grid index, start by setting grid index to 1 plus the floor of grid Y divided by tile size. Now this is essentially just finding the Y position on the grid of the bottom left of the screen. We're dividing it by tile size because one tile is 32x, 32y each. This isn't the full index yet. This is just the Y position. Now we're going to change grid index. Here's where we'll account for the X. Change it by floor of grid X divided by tile size. But we're going to multiply it by, and here you make another new variable, world height for all sprites. Now the world height is, surprise surprise, the height of the world. Remember, when we move over one column, we're increasing the number by the full height of the world, if you remember from the little diagram I showed you. Now we've found the grid index. Now we need to move to the correct position. So we'll set X to tile size divided by 2 minus 240 minus grid X mod tile size. So what in the world does this do? Well, the first part, the tile size divided by 2 minus 240, ensures that rather than being in the very bottom corner, it's a little bit out of the bottom corner, so the full tile is shown. The grid X mod tile size will change it based on where the camera is. So as the camera moves to the right, it will move to the left. Then eventually, once it goes a full tile off screen, it doesn't need to stamp that tile anymore, so it will move back to the one on screen, which is the one to the right of it. Next, for the Y, it's very similar. Set Y to tile size divided by 2. Next, but here we're going to minus 180, right? Because the screen is 180 tall. And grid Y mod tile size. You may know if you've been doing Scratch for a while, it's quite annoying. The sprites can't move off screen, right? They just bunch up on the edge. Well, if we make the sprite bigger, then it can go all the way off screen. We have a big costume for it called off-screen fix. This is big enough to let the tile travel fully off screen if it needs to, so that they don't bunch up on the edge. Now let's get to stamping the tiles. First, we'll move up. The screen is 13 tiles high. Each time, we'll be changing the Y by a tile size and changing grid index by 1. At each position, we will switch our costume to item grid index of grid. So we're finding the tile at the current index of the grid list. Then we'll stamp and switch back to the off-screen fix. Then we can replace this. That's all you need to stamp a column. Now we have 16 columns to stamp because the screen is 16 columns wide. So around this, make sure to encompass the set Y also. We'll repeat 16 times. And at the bottom here, change X by tile size. If this height of the grid is taller than the height of the screen, then we're going to need to change our grid index by more than just 1 here. We'll change it by grid height minus 13. And a fair warning, in my notes, the world height variable is called grid height, so I'm going to keep calling it grid height. Just bear with me. You know what I mean. Now, this is all fine and dandy, but it does nothing if we don't have anything on our grid list to stamp. So, let's write a little bit of code to add some things to our grid list so we can test this out. I'll just code it up, and you can pause the video afterwards and write it up. So here's the code. It'll make a little cube, as it were, of height 10 and width 10. I know it's 2D, so it's not a cube. It's a square. Each column will have a bedrock, and then 5 bits of stone, then 2 bits of dirt, piece of grass, and piece of air. So if we click this, then we should see our grid list is all filled up. It should have a length of 100. Oh, and here, forgive my mistake, this floor block should be inside the times. My mistake, sorry about that. But anyways, I think it's ready to try out. If we press the green flag, see, looks like it's working right. We can move left and up and down. But you'll notice that they repeat up and down. Why are they doing that? Is there some easy way to fix that? Well, the truth is that there may be a way to fix it, but it's not really worth it, because once we have a bigger world, we'll just limit the camera edges so that you can't see these repeations. We still need to do the main point of the video, which is making the generation sprite generate our terrain in the form of tiles. So I'm going to delete the grid as it is right now. We can keep this block here in case we need it. We will be not using that to make our tiles, but instead using our terrain generator. So here, we'll again replace this message with start game. I used a different message for some reason. For now, I'm going to remove the cave parts of these, just so it doesn't complicate things. Let's separate off these for now and just take a look at their generation. You may remember that this is generated in columns. Each column will be 1 tile wide, and we're going to go with a height of 256 tiles tall, which is 128 above the surface and 128 below the surface. Right now we actually have a height of 360, but that gets to be quite big. You can make the height even smaller if you want to, but I wouldn't recommend making it bigger, because that can get a little bit laggy if the grid is really large. So let's remove the refresh pit from the bottom of here and create a new custom block. We'll call it fill grid. So the first thing we want to do is delete our previous grid, our previous world. So delete all of grid. Now we'll set the world height to, we decided 256, and we already set the world width at the beginning of the game, so we do not need to set that. I'm actually going to change it down a little bit so it is more manageable. Now we'll make a new variable called I for this part only, which we will use to loop through our grid. So we'll create a for loop. You may know what a for loop is. If you don't, that's fine. Basically, each time the loop repeats, we change I by 1. So we'll loop through Y positions, each time changing I by 1, and in each iteration, I corresponds to an index of the Y position list. Or in other words, which Y position of the grid is. So each of these times we want to add a column to the grid. Right, we want to add one of these columns. So we'll make a new block, add column to grid. And it's going to have a number, which is the X position. Now in this block we are going to start at the bottom of the column and build up, each time adding something new to the grid. So we'll set the Y to 0. and we'll use the Y to signify how far up in our column we are. At the bottom of the world is bedrock. So we will repeat a random amount of times from 1 to 3. Each time we will add 7 to grid. We're adding 7 because bedrock tile is number 7. Each time we will change Y by 1 because we're going up 1 tile. Now we can add the deep slate. So to add the deep slate, we'll add 64 minus Y because the deep slate layer is 64 blocks deep. We'll add a random amount from -1 to 1 just to add a little variation in the border. And this time we will add 6 because 6 is the deep slate tile. Next for the stone. So here we need to repeat all the way up until just below the dirt layer. So we'll repeat item X of Y positions. So that's what level the surface is on the column at X position X. We'll put that in here. You may remember it goes from 0. 0 is the very middle of the screen, not the bottom of the screen. So we need to add half of the world height to it. World height divided by 2. And from that we need to subtract the Y plus 4. And the Y, right, we need to subtract the Y because we get the difference. And the 4 because of the 4 blocks of dirt and grass. Okay, speaking of dirt, I'm going to repeat 3 times and add 4 to grid. Oh, and this should be 5, right, because 5 is stone, 4 is dirt. And then at the very end, we will add 3 to grid. And then we're going to repeat until we get to the very top of the column and fill with air. So we'll just repeat the world height minus Y, adding 2 to the grid, and then that is our column. And then we need to put the add column to grid here. Add column to the grid I tiles. We can attach this here, and we run it. We get a big wall of deep slate moving up, turns to stone, dirt, and finally grass on top. So here is our terrain. You can see it has our hills. Awesome. You will notice that every now and then we get little 1-block holes like this, or little 1-block outcroppings like this, and they are just a little bit unpleasant. They make the terrain look a little bit jagged and not smooth like we'd like it to be. So we can make a custom block to fix that. Make a block called smooth terrain, because that's what we want to be doing. We will put the block right above fill grid. Again, we'll start with I. We'll make a for loop. Set I to 1. And loop through the Y positions list. Length of Y positions. Each time changing I by 1. Standard stuff. For each of these, we want to check if it's either lower than the 2 Y positions left and right of it, or it's higher than the 2 Y positions left and right of it. If, we'll get an and, if the item to the left of it is lower, so item I minus 1, Y positions, is less than item I of Y positions, and the item to the right of it is also lower. Item I plus 1 is less than it. Then we'll know it is up at turning point, and so we need to lower it. We'll replace item I of Y positions with item I of Y positions minus 1. Alright, now we need to do the same, but for checking if it sticks down. So we'll replace these with a greater than. And replace this with a plus. Let's try that. So if we run along the terrain here, we should find that we don't have any of those anymore. I think this looks a lot nicer. You remember that we have water, right? So let us add the water. That shouldn't be too hard. We'll do it in the add column to grid block. So right here, this section are the blocks that add the dirt and the grass. So if the block above the current, y plus 1, is less than the water level, then that would mean it would be underwater. But remember, the water level is measured from 0, from the middle. 0 is the middle, that is, so we need to add half of the world height to it, just like we did to y positions. Now in the else position, where it is not underwater, we'll put what we have before. In the if position, we'll add 2 bits of dirt. Then we will add 2 bits of sand. Let's check what tile that is. 41. And then we'll repeat water level plus world height divided by 2, and then subtract y. That's how many times we will move up, adding 8. Should we try that? Here we have our water. We notice we have some sand outside the ocean too, which I quite like, and that is what this y plus 1 does, right? So even if it's a little bit further above the ocean, it still gets its bit of sand. We have more biomes than just our plains. We have a forest, we have taiga, and we have desert. So let's add the grass for those biomes. Notice I have a slightly different colored grass block for the forest biome. And then we have sand and sandstone for the desert, and snow for the taiga. Alright, so we'll put that in the else condition. So let's start with the desert. We'll check if item, then we'll use the x from up here. Item x of biomes equals 3. Then repeat 2, we will add sandstone, which is tile 42. And then repeat another 2, we'll add sand, 41. Then otherwise, we will always add dirt. But if it's the plains, if it's biome 1, then we'll add the normal grass. If it's biome 2, then we will add tile number 40, I believe. Yep, and the taiga will be 43. And that will be biome 4. So here we have a desert. Oh, and this biome is a snowy biome. Now you will notice, I forgot to do this, but the water is not animating. It is just standing still. It should be animating. You'll notice we have a whole lot of animation frames, 32 to be exact, and we can animate those pretty easily. We'll make a block called animate. We will stick the animate block right before the stamp. We only want the water tile to animate. So we'll check if the tile, that is the item tile index of tile grid, grid index of grid here, we'll check if that is 8. So the grid index is the index of the current tile that's being stamped, and if at that position, at that index, is an 8, that means it's a water tile, so we should animate it. So we'll just switch the costume to the current costume plus floor of timer times 30. The higher this number, the faster it goes. The smaller the number, the slower it goes. And we need to make sure to mod that by 32. There are 32 costumes, so this means once it gets above 32, it'll go back to 0. So let's try that. Here we go, it's nicely flowing downwards. There's some more. Looks lovely. One thing I do want to do with water is it should be set down a little bit from the surface. It shouldn't be just flush with the surface like this, like it's a solid block. The question is, how do we do that? Because I have so many animation frames. don't really want to have to make a separate one for each different state the water is in, and maybe later if we want to add water physics, don't want to have to make more costumes for each possible position the water could be in. If we go down to the bottom, alright, here we are. We can stamp this on top of the water tile, and it will make it look like it's just air. So we do need to fill this with the correct color of the sky, because your sky will probably be a different color. So just eyedropper the sky, and fill in the thing. Alright, so now we can check if the item grid index of grid is 8. Then after we stamp it, we also want to crop the water. So make a new block called crop water. We'll check if item grid index plus 1, that is the tile above it, is not same item grid index of grid, the current tile we're checking. So if the tile is not water above it, or we could use this on a different tile too, if it's not the same, then we'll switch costume to the water surface crop and stamp. So now if we run over here, see, now it's a little bit lower than the edge of the block. I think that's quite nice. Now our surface area is looking fairly barren. I think it could do with some trees, or at the very least grass or foliage, flowers. We have some flowers here, and we have some tree blocks down here. I'll do the flowers first, because they're simpler. Go to the add column to grid custom block. Now down at the bottom, where we have the grass, might also want to add some flowers here. So let's start with the desert. Here we'll check if random 1 to say 8 is 1, then we'll add a dead bush. Dead bushes are here, tile 59, so we'll add a 59. And then we can't forget to change Y by 1. Next is the plains biome. I will put up the probabilities for here, and then you can copy them if you want or create their own. So here we are. These are what I have. You can look over them and copy them. It's in this block of code. Okay, so that adds flowers up here, tall grass, and short grass. Now in the forest. So this is the flowers for the forest. I know it's really big. You could probably make it simpler if you wanted, but here you go. You don't have to use it all if you want. So this is the 1 tall flowers, these are the 2 tall flowers, and this is the grass. Last is the forest. Alright, so this is the taiga. So this top part is the 2 tall ferns, and the bottom is the 1 tall ferns. Let's run that. Now you see no dead bush, a bunch of dead bushes in the desert, no dead bushes underwater, that's good. We have grass growing in the plains and flowers. Some nice flowers. Alright, I think it's time for the trees. We'll go back to the fill grid custom block. Now, we'll add some more code. Again, set item 1, but this time repeat length of tree positions. And then we'll make a new block called add tree to grid, an input of X, an input of Y, an input of type. We'll add tree to grid. The first number will be item I of tree positions. The will be item I of tree positions of Y positions. The next will be item I of tree positions of biomes. So item I of tree positions is the X. Then that's how we found the Y and the biome. We may add more tree types later, but for now I'm just going to use the biome of the trees and to signify what tree. And we want to add world height divided by 2 to the Y positions, just like we did in the past. Now let's code this block. This will be a block that just has a lot of numbers. Lots of numbers, because we'll just be adding all the different tiles. But before we do that, we need to find what the index of the grid is. So we'll make a new variable called grid index. We'll set the grid index, and here we need to find the grid index. So first we'll set it to Y, and then we'll change the grid index by X times grid height, because remember, each time you move right, the number changes by an entire height of the world. First we'll check for the first tree. That will be type of 1 or 2. Type equals 1 or type equals 2. These will be the standard oak tree. First we should check if the tree is growing on ground, that is, not on water. We'll check if not. Item grid index of grid. This is what tile it is. If the tile is not 3, that is the grass, or if it is not 40, so these are both the grass tiles. If it's not the grass tile, then we'll just move down a little bit and make sure the tile below that isn't the grass tile. Change grid index by -1, and then check again. If it's still not the grass tile, then we know for pretty sure that the tree should not grow. So we'll stop the script. If it does pass these checks, however, we will replace the block at the base of the tree with dirt. So we will replace item grid index of grid with 4. Now we're going to do a lot of replacing grid index of grid with a number. So I'm just going to code up the code for making the tree, and then you can copy it if you like. The code for the trees is right here, and yeah, it looks a bit complicated, but it's really just moving around the grid, stamping tiles. And yeah, you can pause the video if you want and build this up. I do want to slightly increase the probability of the trees appearing so we can just see more of them, so I'm going to change that 25 to say a 10. And we can try that out. Aha, there's a tree. Looks wonderful. There's another one. Now let's do the other trees. So the tree in the desert is a cactus. So that's type number 3. Because biome 3. Here we'll check, instead of being a grass tile, we'll check if it's a sand tile. Tile number 41. Here we can simply place it with, let's look, 67. Tile number 67. And stop the script at the end, that should be simple. Aha, here's the desert. We have a cactus. Another cactus, perfect. Now we have the spruce trees. Type of 4. Here we're going to check if the tile below is a snow tile. 43. Here's the script for the pine tree. Spruce tree, I mean. Alright, let's try that out. Here we are. Here's a nice big pine tree. Here's another. Yeah, those are looking nice. Now, before we move on to the next thing, I'd like to fix a problem with the cacti that I missed. So here we check if it's sand. But remember, the bottom of bodies of water are made of sand. So we need instead to check if they are the air tile, which is 2. Or they could replace dead bushes. So we'll check with an or if it is tile 59, which is the dead bush tile. Now I'm still going to make sure that the block below the cactus is a block of sand. We'll check here if item grid index -1 of grid is sand 41, then we'll stop the script. We should also take our change grid index by 1 and move it up to here, so we make sure to get it out of the ground before we check for the air. Let us try that. Alright, so we should still have cacti growing, which we do, but they should absolutely not grow in bodies of water. And here we have some water, and we don't see any cacti. Now, on the subject of trees, I feel like the forest should have more trees than a plains biome, because, I mean, it's a forest, right? Forests have trees. So, let's go over to our Add Tree custom block. Now here we have this very simple script for adding trees. We can make this a little bit more complicated. So, the top will check if biome equals 2. If the biome is 2, we'll put this one in the else condition. And we will move this block of code up to here, and duplicate this to here. So if the biome is 2, we'll repeat pick random 1 to 2 times. That seems like a lot, right? But remember, the trees need to be spaced at least 5 blocks apart, so this actually won't make them too close together. Let's try that. Aha, here's our forest biome, and we have a lot more trees, much more fitting for a forest. In this custom block, you could add more probabilities for different biomes. All of these oak trees look exactly the same, besides their height. Let's make a list called tree type for this spray only. When we add the X position to tree positions, we'll also add a number to tree type. It's the forest, so we'll add a 2. And the other biomes, we'll add biome. But here, let's say we want some of our trees to be birch trees. We can say birch trees will be type 2, because right now both types 1 and 2 are the oak tree. So we'll get an if else, and we'll check random from 1 to 4 is 1. So 1 and 4 trees will be birch trees. In the if condition, we'll add 2, that's the birch tree, and in the else we'll add 1. Drop this back here. Now in the beginning, we should also delete all of tree types. Go to the Add Tree to Grid custom block. Here, we'll change this to just be a type equals 1. Now we can actually duplicate this block for the birch trees, because they're very similar to oak trees. We'll stick it right down here, type equals 2. For the code for the birch trees, first I'll start by making them a little bit taller, 2 to 4 let's say. And then we'll replace each of the oak tree tiles with their equivalent birch tree tile. 63 will be replaced with 72, 65 with 74, 66. For now, right off the bat, we see some birch trees. You see in the forest, all the trees are birch trees. The reason is, we still haven't modified the fill grid block to add the trees based on the tree type. What we'll do, instead of saying item I of tree positions of biomes, is simply say item I of tree types. Now, in the forest, we should see we have some oak trees. Alright, here we have a birch tree. It's taken me a couple of attempts to find one, so we could consider making them a bit more common. Say, 1 in 3 chance rather than a 1 in 4 chance. Of course, you could add all of your own tree types. You could have variations on spruce trees and oak trees, for example. Let's get back to our fill grid custom block, because we still have stuff to do here. We have our main columns, and we have our trees, but we haven't added our ores yet, or our caves. Start with the ores. Same dealio for those, set I to 1, repeat length of ores. This time we're going to be changing I by 3 each time, because each ore has 3 items in the ores list. We'll remove the add tree to grid custom block, make a new one called add ore to grid. Run without screen refresh. And this one will also have 3 inputs, X, Y, and type. We'll put our new add ore to grid block in here. We'll put item I of ores. That's the X. And then item I plus 1 of ores, which is the Y. And we're going to need to round that. And then add to it the world height divided by 2, like we did before. And in the last position, we'll do item I plus 2 of ores. We can remove this and start to code this block. Now if we look in the tiles right, you'll see I have a whole bunch of ore tiles here. Now we won't use all of them. I'll just use the coal, iron, gold, and diamonds, just to make it simple. These are the ones that you already have code for. But it's very easy to make code for new ores too. Go to add ore, and then make some more probabilities here, right? So temp is the depth that the ore is at, right? So these are the ores that spawn above y negative 60. These are the ores that spawn above y negative 20. And then the rest spawn at the bottom of the world. Now it's good we're in this block, because remember we shortened the height of the world. So we need to change this negative 60. This was previously a third of the depth of the world. A third of 128 is approximately 40. And this one we can replace with a negative 80. There are more modifications to do to the add ore block. Rather than using 1, 2, 3, 4 to determine what ore we're making, we'll use the tile number. 76 for coal, 78 for iron, 79 for gold, and 80 for diamond. And if you look down here, you see we also have deep slate variants in those same ores. So if temp is greater than negative 40, instead of adding pick random 1 to 2, we'll check if pick random 1 to 2 equals 1. And if it does, we will add 76 to ores, that's coal. And otherwise, we'll add 78, that's iron. Now, we'll duplicate this temp is greater than negative 80 and check if it's greater than negative 64. That's the border between stone and deep slate. Again, if pick random 1 to 2 is 1. Here, sometimes we'll add coal, sometimes we'll add iron, and sometimes we'll add gold. If random 1 to 3 is 1, we'll add our coal. And then if random 1 to 2 is 1, then we add 78 or 79, that's gold. Now, for the temp is greater than negative 80. This is when it's below negative 64, so we'll use deep slate tiles. Here we'll add only iron and gold, right? 86 is iron deep slate, and 87 is gold deep slate. At the very bottom is where diamonds can sometimes spawn. Diamonds are number 88. Again, iron is 86, and gold is 87. Okay, now we're finally ready to code our add or to grid custom block. Now, the way we'll do this is we'll start from a certain tile, and then move out, either up, down, left, or right, and then again up, down, left, or right for the new tile. After that, we'll come back and do that a certain number of times. I know that's not a great description, but it will make more sense once we start coding. We'll use our A and B variables to indicate how big the ore deposit is, because different ore deposits are different sizes. If the type is 76 or 84, those are our coal, then the gold ores are usually pretty big. So we'll set A and B to a big amount, A to 4 and B to 2. If type is 78 or 86, which is iron, in this case we'll set A to 5 and B just to 1. If type is 79 or 87, that's gold, we'll set A to 4 and B to 1. If type is 80 or 88, those are our diamonds, A will be just 3 and B will be 1. After all this, we'll repeat A times. Each time we need to find the grid index of the tile. So we'll set grid index to, and then we'll get the x and y variables from up here. Y plus x times grid height. This is the same formula we've used before to find the grid index of a certain x and y position. So we'll just make sure that the tile that is item grid index of grid is not equal to either 5 or 6, and if it isn't equal to either of these, then it isn't a stone tile, and so we do not want to replace it. We'll check up at the top actually. So if it isn't a stone tile, we will stop this script. Back at the bottom, inside repeat A, we'll then repeat B. That's our second variable for determining the size of the ore. Now in here, we either want to move up, left, right, down, or diagonally. And the diagonally is going to happen less often. We'll start with the moving up. If random 1 to 6 equals 1, we'll change grid index by 1. The else, if 1 to 5 is 1, then we'll change it by negative 1. 1 to 4 is 1, change it by world height. If 1 to 3 is 1, then change it by world height times negative 1. So this goes up, this goes down, this goes right, and this goes left. Now, more than half of the time it will move in this manner. But sometimes it will move diagonally. So we'll duplicate this, change this to 1 to 4, 1 to 3, 1 to 2, and this will just be in the plain else. Here we're not only changing it by 1, but also by world height. Same deal here. Here we're changing it by negative 1 and by world height. Here we're changing it by 1 and by world height times negative 1. In the final position, we're changing it by negative 1 and by world height times negative 1. Hopefully this all makes sense. I know it's a bit complicated, but This just makes it go in a random direction, up, down, left, right, or diagonally. Now, at the bottom here, but not at the very bottom, we'll get a replace block. You want to put it after all these, but before the blocks with two little arrows on them. We'll replace item grid index of grid with, and here we're going to get the type variable. This is the type of ore. We'll replace it with type. And then we'll repeat again. So now maybe you see more what A and B do. You should try to make sure to understand this, because that will allow you to make all your own ores, right? You can add all the rest of the ores that I have in the tile sprite. B times, it will move out in a direction, and then it will go back to the center and do that again 8 times. Briefly, I'm just going back into the add ore custom block and change the set temp. Here, we're setting temp from -175 to y-10. We'll replace this -175 with a 0 minus world height divided by 2. And I also don't want it to be too close to the bottom, so I'm actually going to change that to the 5 minus world height divided by 2. And this we can say y-5, right? Because our dirt isn't too thick. And I'm also going to increase the probability. Going to repeat between 1 and 3. So now we should see a lot more ores. Back into the add ore to grid custom block. There's one thing I forgot to do. In addition to replacing the side blocks with ores, we also need to replace the middle block. So we'll put a replace item grid index of grid with type right here, just underneath the repeat A, set grid index to blah blah blah. Alright, run that. So now we should see our ore deposits are not lacking their middle block. The diamond is way too common. So the diamonds are down here at the bottom. I'll just make that a 1 to 5 equals 1. So diamonds should be slightly less common. See how I did that? It's pretty simple, right? You can mess with the probabilities all you like yourself. Next order of business is adding caves. I'm actually going to make the world even smaller for this one. I'll change it down to 240. And the reason I'm doing that is because, if you remember, the caves make the generation quite slow. So we'll stick in the add cave and extend cave block here. Then down at the bottom, before we move the terrain and fill grid, again, repeating 200 times, we're going to extend the cave. Now we can go to our fill grid custom block. We're going to do something very similar. Again, set I to 1, repeat length of caves this time. And here we're changing I by 5. Each piece of cave has 5 items in the cave list. Make a new block, add cave to grid with X, Y, then radius, run without screen refresh. Now we'll put the block right here, item I of caves for the X, and then take this from the ores again, item I plus 1, but this time of caves, and then the radius is item I plus 2 of caves. Now we do have one modification to the add cave block to do. The last episode I forgot to modify the cave radius in the extend cave custom block. We'll get ourselves an if else. We'll dump it over here in some free space. If pick random 1 to 10 is 1, then I'm going to bring our item draw index plus 2 of caves over to here, put it in the else, and the if of it plus pick random -5 to 5 divided by 10. Okay, now this is just very slightly changing the radius of our cave at 1 in 10 times it extends. because item draw index plus 2 of caves is the radius. We'll go back to the add cave to grid custom block, and let's code it. So the way that this block works is that it draws a circle. It starts from the middle point, and then it moves out in a bunch of directions, and it puts tiles in each of those directions. We'll use the actual direction of the generation sprite. We'll point in direction 0, that's straight up, then repeat the ceiling of radius. So that means the bigger the radius, the more times we have to repeat to fill the circle, which makes sense. A bigger circle means more rays to make that actual circle shape look correct. And we'll multiply that by 4. So, because if it has a radius of 1, then it will need to move around 4 times. If it has a radius of 2, it makes sense that it would need to move 8 times, and so on and so forth. Each time we'll turn right 360, that's a full circle, and then divide it by the amount of times we're turning right. We'll use our x and y variables to hold the x and y. We'll start by setting x to x and y to y. And then we're going to repeat the radius so that we're moving out from the center of the circle. We are changing x and changing y. And here, I'm going to basically recreate a move steps block. We're moving slightly less than half a tile each time. So 0.49, and we'll multiply it by sine, S-I-N, of direction. And then for the y, we'll multiply it by cosine, that's C-O-S, of direction. Now, after we do that, we'll set our grid index. We'll set it to round y, then change it by round x multiplied by grid height. And now it's time to replace the block. So replace item grid index of grid with 2, which is the air tile. But not everything we want to replace. I'll get an if block here and put it around here. Now we'll use a contains block to check this, not in a contains. And then we'll put all of the tiles we don't want to replace separated by underscores. So these will be things like trees. And we'll check if this list of forbidden tiles contains underscores on either side of item grid index of grid. If the grid index isn't one of these, then we will replace the item with the air tile. Now, having this here would mean that it would just leave trees floating in the air, which is not something we want. There's an easy way to fix that. We can simply move the loop that loops through the trees to the very end, so it will loop after we've already done the caves. Let's try that. Aha, it appears we have a cave here. Descend straight down this one. Well, it looks like a very nice cave. Okay, wonderful. Seeing this bedrock makes me remember that we should probably include bedrock as one of the tiles that the caves cannot replace. Bedrock is number 7. Don't want any void caves. Ah, yes, like this one. There we go, I was just saying. Thank you, cave, for demonstrating. Well, these caves have certainly made the underground a lot more interesting. Okay, now, that brings us to the end of this episode. It has been a great episode, and good job for you for making it to the end of this video. Because I know this has been a long video and quite complicated, but I think it was well worth it. And now that you have this wonderful tile-based world, I'm sure some of you will add your own stuff to it. Maybe some of you will add a player. Maybe some of you will add, more ores, more biomes, more trees. I'm really super excited to see what you do with this, and I definitely encourage you to add your own stuff. If you ever need any help with things, if you have questions about how things work, please ask them down in the comments. I will answer them. And if any of you want to share your project link, I don't think it will let you do that in YouTube, but because of that, I have a great studio for all the terrain generation projects, and you can find the link to that studio in the description of this video. I hope you have a great rest of your day, and I'll see you next time. Toodaloo!